Hello everyone, and I welcome you all on my YouTube channel Learn with Asher. And in today's lecture, we will be continuing the topic at where we left. So, we were discussing some numerical questions from Conscience Physics for the chapter Force. Moving on with the seventh question according to the book is that a steering wheel of diameter 0.5 meter is rotated anti-clockwise by applying two forces each of magnitude 6 Newton. So according to the question, there is a steering wheel, we know about its diameter, and we also know that in which direction the forces are being applying on it. So draw a diagram to show the application of forces and calculate the moment of forces applied. So first of all, we need to draw the particular diagram. So we need to draw a circle first. According to that, think in this manner. If I am taking this line as my diameter, that means this whole line is of 0.5 meter. Okay, so basically the steering wheel is being rotated in anti-clockwise direction. That means my clock moves in this direction. So I have to move this steering wheel in this particular direction. So where are the two forces being applied? So we can say in this manner that one of the forces will be along this side and one of the forces will be along this side, where this force points at this direction and this force points in this direction. Both of them are of 6 Newton. So this was the question being asked from them, like to draw this diagram. After that, they are asking us to calculate the moment of forces being applied. Okay, so over here what we have to do is that firstly we need to find the radius just comes half of it. So on calculating the radius, we will get radius is equals to half of that of diameter, which is nothing but 0.25 meter. After that, for finding the couple, we will write the moment of couple or the moment of forces is equals to the force, which is 6 multiplied with 0.25. We will be getting as 3 Newton meter. Is this correct? No, it isn't. Why this isn't correct is because, see, the moment of forces is for both of these. So for both of these, I have to add them up. Why I have to add them up? Because both are in the same direction. Okay. So basically in this question, I am having two forces which together builds up the total moment of force. So for that, I have to do 6 multiplied with 0.25 plus 6 multiplied with 0.25. I have to do that at whole. So what I will be getting over here? I will be getting 1.5 plus 1.5, which is nothing but 3 Newton meter. And if you want to write the direction, you can write it in anti-clockwise. So this 3 Newton meter will be my final answer for this particular question. Now let's move on to the next question. And in this next question, it is very important to read out the sentence or the question in a correct manner and point out the important things that we can get from it. So according to the question, they are telling us a uniform meter rule. This meter rule thing is very much important to me. Why this is very much important to me? Because the word meter rule tells me about the total length of the rule which is given to us. So I can write length of the rule is equals to 1 meter, which I can take it as 100 centimeter. Okay. After this, and the pivoted point is at its midpoint. So I can draw a relatable diagram for this one, like in this manner. If this line represent my rule, so according to this particular portion is 0 centimeter, this particular portion is 100 centimeter, This particular triangle represents my pivoted point. Like at this point, the axis is being made, which is at 50 centimeter. So both of these sides are in 50 centimeters each. Now a weight of 50-gram force is suspended at one end of it. I can think of this, like there is a string attached to this and there is a block of 50-gram force. Okay, gram force is in the CGS system. So they are asking us, where should a weight of 100 GF be suspended or gram force be suspended to keep the rule horizontal? So what is my logic over here? I have to provide him or provide the weight at certain distance so that the rule doesn't fall off any of its side, either of its side. So if I suspend over here, it might fall on this side. So yes, I can't suspend this weight on the left hand side. I can suspend the weight on the right hand side. So suppose I am suspending this over here and this is my weight too, which is of 100-gram force, and I'm assuming that overall this particular distance will be d distance at a d distance. So what we can do? Acha, according to the concept of moment of force, the two moment of force are equal to each other. Are equal to each other in which manner? We can say that if this particular force falls down, it will be in anti-clockwise direction. So it must be in the clockwise direction so that the horizontal rule should not fall down. Like in this manner is anti and in this manner is clockwise. Sorry for that. So we can write in this manner, like it was equivalent to force into distance. Force over here can be combined with the weight thing. So I can write weight 1 into its distance will be equivalent to weight 2 into the other distance. Alright. So the first weight is 50-gram force multiplied with what is its distance from the pivoted point? It is 50 centimeter. Follow up with for the weight 2 it is 100, but I don't know at what distance it is being kept. So I have taken it as D. So what will be the value of D? So it will be 50 multiplied with 50 divided by 100. 0 gets off. So it comes out to be 25 centimeter. So what I will be saying from here? I will say that it is 25 centimeter from the other end. And this is my final answer for this particular question. Okay, now let's move on to with another question. And in this question, they have told us a uniform half meter rule. What does this mean? That the rule which has been taken is either 0 to 50 or 50 to 100, like half portion of it. Let us see what more the question tells us about. Balances horizontally on a knife edge placed at the 58 centimeter mark. Okay, a pivoted point is kept with the help of a knife at what point? At 58 centimeter. That means my meter rule must be of 50 to 100 centimeter range. When a weight of 20-gram force is suspended from one end, they have told us a 20-gram force has been suspended, and they are telling us, so draw the diagram of the arrangement. So for that, what I will be doing, same manner, I will take a straight line. In that straight line, I will consider that this end is 50, this end is 100. The pivot has been made somewhere over here. Let us guess in this manner. Alright, so this will be 58 centimeter. Okay. After that, a weight of 20-gram force is suspended from one end. Let us take over here. Alright. I've taken this weight over here as 20-gram force. This is my diagram till over here. Acha, are there any changes to be made? Let us see. What is the weight of the rule? Oh, alright. So I have to find the weight of this particular rule. Always remember, okay, this is very much important, that weight of the rule lies at its midpoint. Where it lies? It lies at its midpoint. So what I have to do over here? So for that, I will consider that this part is my weight thing. Alright. Okay. Acha, what was this distance? This particular half? This was 100 minus 58. So this was 42 centimeter. Alright, I know that 20-gram force has been kept at 42 centimeter distance from the pivoted point. What about this now? Let us think in this manner. So the weight must lie in between over here. So for that to be in between over here, there is some sort of distance between these two. Now what about that distance? That is very much important for me. Alright. So for that, I will be thinking in this particular manner, that there is a something of a rule that we call as the principle of equilibrium. Now what is the principle of equilibrium over here? So according to the principle of equilibrium, it means that there is a force of this in this particular direction, so the weight of the ruler or the rule must be in this direction. Alright. So for that, think in this manner, that if it would have been a full meter rule, the midpoint was at 50. Now if it has been cut out, like it has been taken a half meter rule, the pivoted point has been moved at 58 centimeter. It would have been 50 centimeter, but now it has become 58 centimeter. How much difference there is in between this portion? So we can say that I can take this as 8. Alright. So what I can write is that the weight of the ruler multiplied with 8 will give us 42 multiplied with 20. So what will be the weight of the rule, which is 42 multiplied with 20 divided by 8. So 4 2 times, 4 5 times, and 2 21 times. So we get 105. The unit will be gram force only. Now let us move with the final question for this particular video. And in this question, they have told us the diagram below shows a uniform bar supported at the middle point O. There is a pivot point at this location O. A weight of 40-gram force is placed at a distance of 40 centimeter to the left of the point P. Like there must be have been a point P, and from there at 40 centimeter this 40-gram force has been kept. How can you balance the bar with the weight of 80-gram force? So I know that if there is a weight on the left hand side, to balance this particular bar, I have to keep this 80-gram force somewhere on the right hand side. That is a fixed part, and that is something which is common sense. Like if something is falling in this way, there must be something that must protect this portion. Alright. So what I can do, I can write in this manner. If we can see the distance at which this 40-gram force has been kept is nothing but 10, 20, 30, 40. It is nothing but 40 centimeter. So I can assume that a new weight, which is 80-gram force, must be kept somewhere in the right hand side. So I will assume that it is kept at some d distance. So what I will be writing over here, I will be writing weight 1 multiplied with d1 is equals to weight 2 multiplied with d2. All of these is corresponding to the principle of equilibrium, that sum of anticlockwise must be equal to sum of clockwise moment. So what I can write? I can write 40 multiplied with 40, which will be 80 multiplied. I don't know about the distance, keep it as d2 only. So what I can write? I can write d2 is equals to 40 multiplied with 40 divided by 80, 42 times and 220 times. So this will be 20 centimeter. What does this mean? It means that I will be suspending that 80-gram force of block 20 centimeter from where? From the pivoted point. That is very much important, because many of the students make this mistake that they think, oh, acha, 20 centimeter. So they will think from the end of the rule. No. So I can write over here that the 80-gram force must be kept at 20 centimeter from the pivoted point. Okay. Thank you so much. Do share, comment and like on this video, and don't forget to subscribe to my channel. Let's meet up in the next video.